Okay, so we're going to take a look at a couple of examples of calculating area of or using area to solve for x, or just doing some more involved examples than the previous example, the previous video where we just had the length and the width of a rectangle, and then we inputted that information into our formula. All right, so here, let's say that we had this figure here. So we have a rectangle here, and then okay, and then we also have a diagonal here, and we are told here, given that we have the length here is x, the length here is x plus 2, and then the length here would be x plus 4. And our goal here is to find x. Okay. Okay, so if our goal here is to find x here, right, now looking at this, we can see, right, we have this rectangle with the diagonal here. But really what is going to be helpful here is what the diagonal creates is a right triangle. So I know if I have a right triangle here, then I can, so find x, and then let's say also find area of rectangle. Okay, so I'm going to use first the Pythagorean theorem to find the value for x. All right, so looking at this here, the Pythagorean theorem tells me the sum of the squares Okay, so here, be careful, make sure that you FOIL this out, right? So this is not simply x squared plus 4. This is x squared plus 4x plus 4. Right? Don't forget those middle terms as you expand that, x plus 2 times x plus 2. And the same thing here on the right side, we'll get x squared plus 8x plus 16. Okay, so here I can combine like terms here. So we'll get 2x squared. So it looks like I'm going to have a quadratic equation. So as always with this, the quadratic formula would work. Right? The first step in doing that is I have to set it equal to 0. Okay, so here I'll subtract subtract x squared, subtract 8x, subtract 16, right, from both sides. Okay. All right. So that leaves us here on the right side, these all go to 0. So on the right side we have 0. Here we'll get x squared minus 4x minus 12. Okay. All right. And again, like I said, the quadratic formula will always work, right? Here the first step I like to do is, can I factor this? So I need two numbers that multiply to a negative 12 and add up to a negative 4. So here, since this coefficient is 1, That first term will always be x. All right, and I think those two numbers are going to be -6 and +2. All right, so both multiply to -12, add up to a -4. All right, okay, so there we go. Now once we're here, now I have my solution, right? X equals to 6, x is equal to -2. All right, by setting each one of those terms equal to 0. Now here, when we're dealing with physical quantities, let's make sure that our answers make sense. Does it make sense to have a value of 6 for x or -2? So I'm going to scroll up here to my initial figure, right? So 6 doesn't give me, is okay, mainly because what I'm looking for here is in my rectangle that the lengths need to be positive, right? And that works out fine here, right? The problem I'm going to have is when I get a value for -2, it does not make sense to say that the length of this rectangle is -2 units. So here, all right, in our application, while algebraically this is correct, in our application we only have one rectangle and x is equal to 6. All right, so now let's go back here. If x is equal to 6, that means that we have a rectangle of length 6 and width 8, right? 6 plus 2 is going to be 8. All right, so now the area part should be as easy as multiplying 6 times 8, which is what, 48. And again, make sure that you write the units squared. All right. Okay. All right, so now let's take a look at another example here, right? So a slightly different example. Here we're going to have a figure that does not look like well, it's not a rectangle. That just doesn't look like one. Okay, so I want to assume that all these corner angles here, these are all going to be 90 degrees. All right, and I'm told that this is 14 feet. This is 10 feet. This one here is 18 feet. And here we have 8 feet. Okay, and what I'm asked to do is find the area of the figure. Now, at first when I see this, I'm like, okay, well, this here does not look like a rectangle, but it looks like I can at least kind of chop it up here so that I have more than one rectangle. In this case, if I continue across this straight line here, I can continue it where I have 2 rectangles. All right. So here I have this one right here. We'll call this one rectangle 1 and this one rectangle 2. Right, so the goal here is going to be, right, I can find the individual areas of 1 and 2, and then the total area would just be area 1 plus area 2. Okay, so looking at this, I could say for triangle 1, right, length and width, that one's straightforward, right? 8 times 18. All right, so that's going to be, what is this? 8 times 8 is 64. 8 to 40. All right. Okay. So we get 144. Watch the units here. So this is going to be feet squared. Units important, right? So we're going to make sure that we write the units in all of our problems. Excuse me. Okay. All right, so now let's take a look at 2. So I do know the width here is 14. Right? But I'm not given, at least right away, the length. But actually, it's not that hard to calculate from these other two values that I'm given here. So from here to here is 10 feet. And then from here to here is 8 feet. So total across here we'll have 18 feet. All right. Okay. So then the area for 2 is going to be 18 times 14. I don't have my calculator handy here, so let's just do a quick. All right, so what are we looking for? 18 times 14, right? 18. So 252. So we get 252 feet squared. All right, but again, not done with my problem here. My problem was find the area of that figure, so that I'll label as the total area. So the total area is simply 144 plus 252. And this is what, 6, 9, 396. Make sure that your final answer has the proper units. Okay, so that is how we calculate the area of a figure like this.